Welcome back. We've got another topic for today. It's going to be these guys, exponential functions, and how do they affect your graph. Well, it can be written as f of x or y equals. The rest of it will be pretty much the same. You can use different letters depending on what book you're using, but the key is this x should be an exponent. You're going to have a base, you're going to have something multiplying by the base, maybe, maybe not, and you have h and k or c and d, doesn't matter, it'll be something like that. Now if you recall, a couple days ago we did this one, absolute value functions. They look a lot alike. This is different, but I've got an x minus h, I've got a plus k. They serve almost the exact same purposes. So if you have these notes from the other day, this will help out a lot. In our notes, the a value is going to be our dilation factor. If a is positive, then it's it goes up. It could be like this, or it could be like this. But it's going to be up. If a is negative, it'll be going down. Like that, or like that. This is also a dilation factor. It tells you how steeply it's going up or down. The closer it is to zero, the slower the slope is, or the slower the arc is. The bigger the number, like 10, 20, or 100, it shoots up really quick, or it goes down really quick. Okay. Here's our base. The base can be any number. So a lot of people put these two together, but they can. Your base will usually be a simple number like 2, 4. It can never be 1. So this note down here says, if your base is bigger than 1, then you have what's known as an exponential growth. If it's between 0 and 1, then it's exponential decay, or it's a shrinking function like this, or like this. Oh, wait, no, this one. That one's shrinking. Okay, it'll be a shrinking. We'll see some examples on the next page. Your h value is the same as it was in the other function. That's your horizontal translation. This makes you go left or right. Always do the opposite of what your x tells you. So if x says plus 5, you're going to go left 5. If it says x minus 2 in there, in this parentheses, you're going to go right 2. Not minus, not left. You're going to go right. And your last number out here is your k value. That's your vertical translation. If you do it, what you see is what you do. If it says plus 9, go up 9. Minus 8, go down 8. All right, let's do a couple of graphs so you see what I'm talking about. We got a couple graphs here. This is the most basic exponential function. The number 2 to the power of x. Well, how does this work? 2 to the power of, and that's your power button, let's say 0. 2 to the power of 0 is 1. So my input, when my input is 0, my output is 1. So I'm going to put a dot right there. 0, 1. When my input is 1, my output is 2. So 1, 2. 1 and 2. Input is 2, output will be 4. Well, that makes sense. 2 to the second power means 2 times 2, 4. If I go to the third power, it's going to be off the chart. It'll be 3, 8. So it's up here somewhere. So that's my graph. I can also do negative numbers. Negative 1, I'm going to get a half. So at negative 1, I'm at 1/2. These are all valid points, valuable points. Okay, let's say I'm going to do this. Since it's outside the x, we're dealing with a vertical translation. This should make it go down 3. Let's try it out. Go to our original ones. 2 to the 0 power, 2 to the 0, minus 3, negative 2. So when I put in 0, negative 2. Okay, let's do another one. Instead of 0, go to the first power. 2 to the negative 1, right, 2 to the first power, minus 3, is negative 1. Well, that's just like these two dots. 1, 2, 3, 1, 2, 3, they match up. Let's try another one. Second power. Second power, I'm going to get a 1. I think I can fit the third power on here. Yep, third power is 5. Well, let's go to the negative 1 power. Negative 2.5. These look just like these guys. Bam, bam, bam. This one was off the chart. Everything got moved down 3. What you're going to notice is this never crosses this line here. Ooh, so close. It will not cross this line. That line of negative 3, it can't cross it. So it's going to run along it. Okay, let's try this one. Negative 1. So now what I'm doing is, I'm doing a dilation. I'm putting a negative 1 here. So if it's negative, it should go down. Let's try it. Negative 1 and 2. Negative 1, parentheses, 2, power of 0. Negative 1, so 0, negative 1. First power, negative 2. So first power, down negative 2. Second power, negative 4. I think it's going to go off, so I'm going to go to a negative 1 power. Negative half. Well, this is going to look like this. Which is identical to this one, just flipped. So this is a translation across the x-axis. Here's my axis of symmetry, or line of reflection. This one came down here. Okay, let's try another one like, we're going to take this one. Y equals 2 to the power of x plus 4. This is all an exponent. It's not on the same, it's raised up here as a power. So how do you do that? Well, let's clear this out. 2 to the power of parentheses 0 plus 4. Off the charts. Okay, I can't do 0, it's off the charts. Let's go smaller. Negative 2 plus 4 is 4. So negative 2 input, output is 4. Okay, let's go and change that to a negative 3. Negative 3 input, output is 2. Negative 4. Output is 1. Negative 5. Output is a half. Negative 6. Output is a quarter. So these 3 dots went to here. Boom, boom, boom. This one and this one are the same. Wait. Yeah, this one and this one are the same dot. How far over did it go? 1, 2, 3, 4. 1, 2, 3, 4. So the plus 4 moved it left 4. Let's try one that has y equals 1/2 to the power of x minus 1. Let's see if this works. 1 ABC, 1 ABC 2 to the power of 0 minus 1. Does it work? It says 2. So in this situation, if I put in 0, I'm going to get a 2. All right, let's put a 1 in. We get a 1. Okay, let's put a 2 in. I get a 1/2. Okay, let's put a 3. I get a 1/4. 4. 1/8. Okay, it's never going to get down to 0. It'll get close, but never touch 0. Well, let's try a negative number. -1 minus 1. +4. -1, +4. Remember what I said earlier? If this base is between 0 and 1, it's going to shrink. Well, this is shrinking. It's very much like this one, but flipped this way. 1/2 and 2. This one just got slid down. These two are much more similar, but this one moved to the right one. This one went this way. Yeah, okay. That should be enough. If you need more, we can talk about more some other time. Thank you.